Hello, welcome to Math 043 Compound Inequalities and Interval Notation. You can read the top of this worksheet, but I want to point out that the following chart illustrates the different forms that can be used to describe the solution set. So in the first column, you can see how the solutions can be written as an inequality. The second column is the interval notation, and the third column is the number line. You will notice that when you have a less than or greater than, you will need to use a parenthesis. If you have a less than or equal to or greater than or equal to, it is a bracket. That is the notation that we need to use. So let's get started. Example 1. Graph the following inequalities on a number line, then write the corresponding intervals. So if we have x is greater than -2, we are going to put a parenthesis on -2. And since x is greater than -2, we will shade to the right. You might want to put positive infinity on your number line because the interval is going to be read from your number line. We have a parenthesis on -2, and we go all the way to infinity. Infinity always has a parenthesis, never a bracket. The other thing I will point out, if your variable is on the left side of the inequality, then you will always shade in the direction of the inequality sign. So x is greater than, it's pointing to the right. I'm going to shade to the right. B, x is less than or equal to 3. We need a bracket on 3. X is less than or equal to 3. We shade to the left. So our interval is going to be -infinity to 3. Again, the variable is on the left. We shade the direction of the inequality, so we're shading to the left. And then you will always write your interval in ascending order. So the smallest number is on the left, and the largest number is on the right. Letter C says -2 is less than or equal to x, and x is less than 3. In this case, x is between -2 and 3. Since x is greater than or equal to -2, that is a bracket, and x is less than 3 is a parenthesis, and we will shade in between. So x is greater than or equal to -2, and x is less than 3. So to write this as an interval, just read it off your number line, bracket -2, comma 3 with a parenthesis. Letter D, x is greater than -2. Or x is less than or equal to 3. An or statement means all possible answers. So we can clearly see that our number line is shaded end to end. So our answer is negative infinity to positive infinity. And we're going to get more into ors and ands here in just a second. Basic concepts. A compound inequality consists of two inequalities joined by the words and or. The following are two examples of compound inequalities. And you can read number 1 and number 2. The difference between and or is very important. If a compound inequality has the word and between the two inequalities, a number must satisfy both inequalities at the same time to be a part of the solution set. For example, the solution to x is less than 5 and x is greater than -2 would only include the numbers that are both less than 5 and at the same time greater than -2. On the number line, it would look like this. So what you are looking for with the word and is an overlap. So our answer for our interval would be -2 to 5. When you have the compound inequality or, you are looking for all possible answers. If a compound inequality has the word or, a number need only satisfy either of the inequalities to be a part of the solution set. For example, the solution to x is less than -3 or x is greater than 2 would include any number that is less than -3. It would also include any number greater than 2. On a number line, it would look like this. As an interval, the part that is shaded on the left side of our number line is from -infinity to -3. There is a gap, which we use the union symbol, and then we start again from 2 to positive infinity. The union symbol looks like what I have drawn. It is not a U with a tail on it. It simply looks like that. All right, let's do some more. To solve a compound inequality, solve each of the inequalities separately, then determine the solution set of the combined inequalities, making sure to use the word and or that is given. Example 2, solve each of the compound inequalities and write your answer in interval notation. So we'll subtract 1 from both sides. Divide both sides by 2. X is less than or equal to 2. and negative 3x is greater than 9. Recall that when you divide both sides of an inequality by a negative, you need to reverse the inequality sign. So x is less than negative 3. I'm going to do a little more work on my number line. The compound inequality is and. So we're looking for where they overlap. They overlap from negative infinity to negative 3. Now, just for fun, what if it would have been the same problem, except we would have had an or for our compound inequality? Our answers aren't going to change. But this time, if we have the word or, we're looking for all possible answers. So in that case, our answer would be negative infinity to 2, because we would take all possible answers. All right, let's keep going. Letter B. Let's solve each inequality independently. Divide both sides by negative 2, reverse the inequality sign. Graph them on a number line. The compound inequality is, a compound word is or. So we need all possible answers. So our answer, we have the interval from negative infinity to 1, union with the interval from 3 to positive infinity. All right, letter C. Again, solve the inequalities independently. The compound word is and. We're looking for an overlap. And since there isn't an overlap, the answer is no solution. And if you notice, the next example is the same problem, but this time it has the word or. So we'll have the same work, same number line, but since it is an or, we want all possible answers. So we have the interval from negative infinity to 2, union with the interval from 4 to positive infinity. So be sure that you notice the compound word and you're looking for an overlap or you're looking for all possible solutions. So in the next part, we will be given 3-part inequalities. And in this case, you're going to do the same operation to all 3 sections. So in the first example, we have 2x plus 5 in the middle. We want to isolate x. So let's subtract 5 from all 3 sections. And then divide all 3 sections by 2 and simplify. So we'll put this on a number line. We have a bracket at -4, a bracket at 3.5, and x is between. So we'll shade in between. To write your answer as an interval, we have a bracket on -4, comma 7/2, and a bracket on 7/2. And letter B, in example B, we have a fraction. So I suggest we clear the fraction. So let's multiply all 3 sections by the denominator, which is 3. So I'm going to multiply all 3 sections by 3. -1 times 3 is -3 is less than or equal to 2x plus 5 is less than or equal to 9. Now it looks just like the previous example where we will subtract 5 from all 3 sections. And divide everything, all 3 sections by 2. So x is greater than or equal to -4 and x is less than or equal to 2. So our numbers are like our bookends, and then x is between them. So to write it as an interval, we would have a bracket, -4, comma 2, and a bracket. And last but not least, example C. Let's isolate the x by subtracting 2 from all 3 sections. Now we're going to divide by -5. When we divide by -5, we must reverse the inequality signs. So we have 2 is greater than or equal to x, and x is greater than or equal to -5. All right, this is in descending order. We want the smallest number on the left. So I'm going to rewrite this in ascending order. These two are the same. If the arrow is pointing to the -5, it is still pointing to the -5. The arrow is still pointing to the x. The arrow is still pointing to the x. And back in the day, if you learned the alligator eats the bigger number, the alligator is eating the 2. It's still eating the 2 over here. So just know that those two are equivalent. They are the same thing. But now we can write it on our number line. So we have a bracket on -5, a bracket on 2, and we will shade in between to write this as an interval. That's how we write it. That's all I have for this lesson. See you next time. Bye.